Welcome everyone to this live stream. I wanted to quickly discuss what I found and some summary regarding the Apple Silicon that you probably have seen. So Apple Silicon means so we're talking this fine little stuff here, right? Of new and yeah. So first off, so the event video, I didn't find the most outstanding. I know many people it's like, yeah, amazing, but honestly, I found it somewhat boring. Yes, the animation up and down, but I mean, seriously, yeah, what for your PC is the animation, but even the animation I found kind of boring. And most of the time it was like, yeah, let's go and give us some technical details, but yeah, anyway. Also in this artificial lab, it's like, also beside, I wanted this, I was in some Airbnb before the pandemic some year ago, and they had like bar chairs like this, and they were so bloody uncomfortable. I really wonder who would want to work, or maybe they just removed all the normal chairs, or anyway, this looks a little bit funny to me, but just some side anecdotes. Of course, the presentation lacking all the technical details. So if you're looking for hard numbers, there is not much to find here except the power. And even then, from the presentation, I was vastly disappointed due to the nature of this, yeah, faster than 97% and stuff. The hardest technical number you find in here is a third of the power in Apple's M1 compared to latest PC laptop chip. It's also like, yeah, which like Intel something probably maybe. So from that I found this mostly, yeah, for me it's rather sad that Apple became a company that is pure marketing and not, well, it certainly always was marketing, but we don't get any number of clock frequency of anything. So yeah, if you look for stuff in this presentation, it's like, yeah, whatever, something colorful. So coming to the hard numbers, so after this presentation I thought, yeah, okay, due to the nature of this vaporware 97 faster than 90%, I thought 90% of the PCs shipping some old Intel garbage, it can't be too good. And here are the first results of other people, because obviously this is not the final Silicon, so this is 812Z, which I can't talk about due to NDA, right? And so some other people uploaded here some stuff that thankfully isn't from me. And if you compare this with the Apple developer prototype transitioning kit here, I think this probably should have been, the performance is quite a bit higher, so nearly not like double than the developer transition kit DTK. But here we have some 25 something single core, and not really double, like 50% or something if we eyeball this. But the much more interesting thing, and now fasten your seatbelt and buckle in and stuff, if we set here this baseline, so this is the fastest, or one of the fastest Ryzen 5950X here, 5950X. So this should be baseline. So the only thing is this is a little bit annoying. So we might need to reload this twice because modern web stuff, because yeah, baseline URL. And does it work often? Yeah, it did not work. Let's do that again. Maybe let's better click on remove and edit again, because web is hard, as is, hey, 0 frames. Yeah, not really. Hello, can we? Oops, shit. Yeah, maybe this doesn't do anything, but can we also reload this? Hello, come on. Did we load this? Loading slow for whatever reason, that's the internet. So let's click there, set it to baseline. Sorry for the slow web stuff. And good afternoon and welcome everyone. I also wish it would be faster, but it isn't. With 500 Mbit, it's like heavy loaded, so queue is full. There we have it. Their stuff is overloaded. So this is resetting this baseline, as I said, and so this is crazy, right? So there's also a difference, right? Apple, in my opinion, super boring, lame presentation of, yeah, we are faster, we're the best, one certainly believe us, 97% shipping PCs, whatever. So Apple, so fun fact, so Apple has some really amazing silicon, and the presentation as of 2020, in my opinion, presentation so boring and whatnot that yeah, I actually thought they don't even have that much. It's fastish, but yeah. But look at this. So what does this show us? This shows us here that the single core and of course AMD Ryzen significantly faster in the multi-core score. But just look at this. The single core score of this M1 Apple Silicon, by the way, it's 3 point something gigahertz. So this is maybe even slightly lower clocked. So super competitive single core performance, and this is relevant because this gives us all the key features of the CPU of the SoC, which is also probably could mark this in full, which is the IPC. The instructions per clock is amazing, and I will show you in a second or minute why and how. But of course the multi-core, this only has 4 big and 4 little, I think. It's a pseudo. Of course, Apple, being Apple, they advertise this as 8 core. But of course, it's 4 big and 4 little cores. So yeah, 4 low performance, higher efficiency cores. And if, by the way, we could, let's, yeah, also we have here this tiling manager. Let's compute here something quickly. Actually, I should have done this before the video, but time and money and stuff. If we multiply this with 32 threads, okay, this probably is more like 16 for that. So yeah, it is a single core. So if this would be, by the way, does it scale if we say 4? Yeah, 4 big cores. So this somewhat scales. Of course, for 4, if we take in account 4 big cores and we reach this, it's okay, 4 little cores as well as like maybe 7,000. But so if this would be 16 real cores, 16 big cores, so people wondering, can Apple pull off their own silicon stuff with the iMac Pro or the Mac Pro there on wheels? Then yeah, this is certainly plausible, right? 16 threads, 26,000 if it somewhat scales, even with some scaling and memory limitation, bandwidth issues and stuff. So how did they pull it off? And of course Apple, actually I wanted to open something else. But nothing better than Googling this here live on this channel. What? Pamela power efficient? No, PA semi power. And so of course, Apple being Apple, they make it sound like, yeah, it's like magic. We have done magic. No, they have not done magic. And let me explain. So Apple purchased in like 2005 or 2008, PA Semi. So I think what is behind most of this is PA Semi. The company, fabless semiconductor company, started in 2003 for power PC efficient stuff, and that even was in the talks back in 2004, 2005. There were rumors that Apple might switch from IBM 970 MP to PA Semi power efficient. And by the way, one of the things I still want to get hold on is this power efficient. There are some boards in Amiga X1000, so there are, it's possible, but of course in the meantime 15 years old. Anyway, so they acquired that, Apple acquired PA Semi, and with this pretty good 150-person engineering team. So it's not like Apple, of course, and that is of course all the Apple fanboys like, yay, Steve Jobs or Tim Apple has done it again. But yeah, of course this was 15 years in the making. It's not like it fell from the sky just the 5 last years. In contrast to what this Apple event of, yeah, unheard. They often, Apple said so often unheard. Honestly, they mostly catched up with the industry. So like unheard is only that they just extended their mobile, well, not just, but they, with this team over 15 years, built their own Apple Silicon, aka ARM, And also many people often in the Discord or other corners of the internet ask me, but Apple did not design their own cores. Yes, they have designed this. All this stuff are their own cores, because otherwise they wouldn't also be that much faster than other ARM cores from Samsung and so on. So how did they have done this? So this is PA-Semi, power efficient, and just of course developed over 15 years, and certainly in the meantime probably a team of 1,000 or so. So it's not like unheard of, like, yeah, just so if you want outstanding silicon, just gather a team of 1,000 amazing good people and work 15 years. And yeah, so how have they done this? And this is also two things before people tune out. I made a couple of videos, which I could also have opened, and which is instruction set architecture. And in those videos that you probably want to look at some rainy day or later this winter, I went over the details of x86 and also not ISA cards, but RISC-V, ARM part 1 and 2 for 32 and 64-bit, PowerPC, SPARC, RISC, SPARC, MIPS, RISC-V, what is different. So there are a couple of previous videos. And in the previous videos I said, so not only ARM64 is of course a relatively good instruction set architecture, and in general RISC-V, the new and totally open architecture, is also super amazing. And a lot of people always argued, but x86 is amazing, and CISC, the CISC versus RISC, and even other outstanding FPGA design tools, people on Twitter then argued with me like, don't you know that RISC and CISC is largely irrelevant for 15 years? But with that in mind, in my opinion, this Apple M1, I only wish they would use better namings. They should have named this A14-8 or something for A14-8 cores or something, but naming and stuff, but at Apple becoming a little bit of a mess. Here are amazing people at AnandTech who have analyzed this much better than I have time for, and you probably want to read this article. And here are some key takeaways that I want to present to you. One is that so how do they manage this performance? So first of all, in my opinion, it proves that RISC stuff like ARM and RISC-V, that people always argued with me like it will not be as fast as x86, when I always said x86 is such a chaos. If you take the same execution units and setup and caches and reorder buffers and everything with just an ARM or RISC-V front end, you will have the same, if not even more amazing performance. And that is exactly what Apple has done here. And so this article is based on the A14, which they analyzed based on the existing iPad and iPhone silicon stuff. And when you look at this, M1's 4 Firestorm high-performance CPU cores, notice a large amount of cache. The 12 megabyte cache was on the surprise reel on the event, as the A14 is still only featuring 8 megabyte of L2 cache. So yeah, previous videos, I made also another video, Intel Ice Lake or whatever that was, it's like, yeah, just double the buffers and stuff. So you want 5% more performance, just double all the caches and buffers. So already big caches and now even bigger caches. And 3 large blocks, something meanwhile, they also have super large buffers. And this is crazy. These numbers will, I hope you're sitting and fasten your seatbelt. Let's see, where is that? Probably here. Apple's humongous CPU architecture and so buffer. And they benchmarked here with assembly programs, probably the amount of out of order window for instructions. And they found that, and again, not reading the whole article for, certainly you should read them and read the advertisements and stuff. Just have a sneak peek and summary. The latest, so how deep is out of order execution capabilities? And these numbers are just mind-boggling. Latest official release they had was 192 figure for the reorder buffer instead of inside the 2013 Cyclone design. And they are now at, let's see, they could confirm that the Firestorm reorder buffer is a whopping 630 instructions range deep, which is crazy, right? So this means this CPU can have 630 instructions in flight out of order execution, which is like not 8, not 16, not 64, not 100, not even 512, no, 630 instructions. That is basically a whole subroutine stuff. And then additionally, so this is of course already deep and immensely huge out of order window, and it also, they write here, also vastly outclasses any other design in the industry. Intel's Sunny Cove and Willow Cove cores have a second most deep out of order design with 352 reorder buffer, while AMD's latest Zen 3 core makes with 256. So there you have it, right? ARM, latest and greatest state-of-the-art ARM silicon there at Apple. And this is also what I said always, that x86 is too complex, and they also even read this here. So underlining my previous videos, variable, I think they even wrote here that also, yes, this is, and additionally to this, you also need a wide instruction decoder to feed all your many ALUs and execution units. And if you look at the x86, and so we are not comparing here some apple with oranges, we are comparing with the leading edge performance, x86 performance here, outstanding designs. Other contemporary designs such as AMD Zen 1 through 3 and Intel's MicroArch architecture. x86 CPUs today still only feature a 4-wide decoder design. Intel's 1+4 is seemingly limited from going wide at this point due to the instruction set. So all my previous videos, right, when people, it's like, yeah, don't you know that risk versus RISC is vastly irrelevant these days and so on. It's like, no, it's not vastly irrelevant if your instruction set is already highly complex and you can't scale your silicon front ends and decode units in a way. Because what is the issue? Previous videos, x86 is a variable length instruction set. Instructions can be anything from 1 to, was it 16 bytes? And this certainly can't nicely be done in parallel. And at ARM, you have either always 4-byte or maybe compressed previously 2-byte. I forgot how it was with 64 right now. But RISC-V also has a compressed extension. So this means at least not 1 to 16, but only 4 and 2 bytes. And so that multiple decode units can issue multiple or decode multiple instructions per clock cycle. And the Apple Firestorm CPUs industry just sheer width of featuring an 8-wide decode block. And so Apple for mobile kindish class compact silicon or iPad or Apple M1, it's like, yeah, what you only have 4, you world class for x86, you have 4-wide decode design. We can 8-wide decode, so they can decode 8 instructions per clock cycle. Far the current widest commercialized design in the industry. IBM's upcoming P10 core and the Power 10 is the only other official design that's expected to come to market with such a wide decode design, following Samsung's cancellation of their own M6 core, which was described as being a design with such a wide design. So in summary, this is world-class leading edge performance, much better than, in my opinion, the relatively boring and technical detail lacking Apple presentation was giving. Where do we even have this here? So yeah, if you're interested in boring stuff, then that probably is for you. Also MacBooks, now we moved MacBooks now with double escape key, one real escape key and one in the touch bar. But otherwise, just what I said, more regular, reduced instruction sets, much easier to implement in silicon, and as senior in this Apple design, thank you Apple for proving me right, you can much more parallelize this. It was only a matter of all the ARM companies so far not having as humongous designs, and Apple being the first one with the amazing PA Semi design team and all the likely hundreds of engineers they poached from every company over the last decade, basically created an unchallenged and unparalleled ARM64 design that as far as I've seen no other company currently has. I'm wondering, of course there are some server ARM designs from Google and Amazon or something, which is also, in my opinion, rather silly these days, that Amazon and Apple and Google need to have their own CPUs. This is a little bit getting out of hand. There are some more remarks. Should we do this in this video? Maybe we go online in a second video just to have this separated. So as many things I don't like, including the presentation at Apple, I congratulate them to an industry outclassing design here, on par with Zen, AMD Zen 5000 series, as seen here in the single core score with probably turbo boost here and less frequency there. So maybe if you scale this to the clock frequency, this might actually be higher performance IPC than AMD's current Zen, which is certainly amazing. Unfortunately, the Maxes are not as amazing. It's probably, let's continue second video, my other thoughts of the state of Mac and this